we will be discussing about average and instantaneous rate of change of a function. For this, let us consider a particle which is moving along a straight line in which is described by the equation S equal to f of t. Clearly, the distance covered increases with increase of time, then the average rate of change of S with respect to t is given by the ratio delta S by delta t equal f of t plus delta t minus f of t over delta t, which is called the average velocity of particle during the time interval t comma t plus delta t. Thus, average velocity BAB equal delta S by delta t equal f of t plus delta t minus f of t over delta t. The limiting value of delta S by delta t when delta t tends to 0 is called the instantaneous velocity of particle in time t. Therefore, instantaneous velocity v equal limit delta 0 del s by del t equal limit del t tends to 0 f of t plus delta t minus f of t by delta t. This is first part. Now derivatives of some standard algebraic functions. Derivative of some standard algebraic function. This is from the first principle. Or it is called by definition. It is also called by the definition. We have to discuss now. According to first principle or by the definition, that means the same. Firstly,
पहला कुछ स्लाइड लगा जिनमें थैंक यू
from the first principle or by the definition we will be discussing. It is important to find the derivative, which will be the formula later. First of all, a constant function. We will be taking y equal to f of x equal to c, where c is a constant. We are discussing or we are finding the derivative by the definition or by from first principle of the constant function. Here y equal to c is a function. Let del x be the small increment we can suppose this is as y also. Del x with a small increment in x and del y be the corresponding small increment in y. Then y plus del y equal to c. Second equation minus first equation, y plus del y minus y equal to c minus c. There is a constant, so there is no increment, because if there is x term we will write x plus del x, so this can be cancelled. Del y equal to 0. Now dividing both sides by del x, del y by del x equal to 0 by del x is 0. Now after that, taking a limit is del x tends to 0, then then limit del x tends to 0, del y by del x equal limit del x tends to 0 of 0. It is called by definition limit del x tends to 0, del y by del x is dy by dx, that the derivative of this limit del x tends to 0 is 0. In this way, therefore the derivative of constant functions is 0. Okay, dear students, now we have to find the derivative of y equal to f of x equal to x square from first principle. Question. So we have to find the derivative of x square from the first principle. Let y equal to x square is the first equation. Let del x be the small increment in x and del y be the corresponding small increment in y, then y plus del y equal x plus del x whole square. It is the second equation. Then second equation minus first equation. Now we can find del y equal x plus del x whole square minus x square, because y can be cancelled. Now dividing both sides by del x, then we get del y by del x equal x plus del x whole square minus x square over del x. Now taking limit as del x tends to 0, we get limit del x tends to 0, del y by del x equal limit del x tends to 0, a square minus b square you can apply here, x plus del x plus x plus del x minus x whole over del x, a square minus b square, a plus b, a minus b. Or by the definition, this is dy by dx whole this, and limit del x tends to 0, can be cancelled, and x plus x is 2x plus and del x times del x over del x. It can also be cancelled. Limit del x tends to 0, 2x plus del x. We have to apply the limit. I know del x tends to 0 on 2x. Therefore, dy by dx equal, therefore dy by dx equal to 2x. We conclude that the derivative of x square is 2x. And another method, dear students, let f of x equal to x square, then f of x plus h equal to x plus h whole square. By the definition of derivative, f dash x, it is also called derivative, f dash x पनि भन्छ. Limit h tends to 0, f of x plus h minus f of x whole over h equal to limit h tends to 0. What is f of x? That is x plus h whole square minus x square over h equal to limit h tends to 0, x plus h minus x plus h plus x over x equal to limit h tends to 0, h times 2x plus h by h equal to limit h tends to 0, 2x plus h equal to 2x. h tends to 0, 2x. Therefore, dy by dx equal to 2x. This is another method, or derivative of x square is 2x. In this way, we find the derivative of x square as well. Okay, now y equal to f of x equal to x to the power n, x belongs to q, that rational number. By the first principle, we have to find the derivative of this. For this, let y equal to x to the power n, that first equation we have supposed. Let del x be a small increment in x and del y be the corresponding small increment in y. Then y plus del y equal to x plus del x to the power n. We consider this as second equation. Then second minus first equation, dear students, del y equal to x plus del x to the power n minus x to the power n. dividing both sides by del x, del y by del x equal to x plus del x to the power n minus xn over del x, taking limit is del x tends to 0, limit del x tends to 0 del y by del x equal limit del x tends to 0 x plus del x to the power n minus x to the power n over del x, or by the definition limit del x tends to 0 del y by del x is dy by dx equal, we have to manage this part, limit x plus del x tends to x, and x plus del x to the power n minus x to the power n over x plus del x minus x. Let me check once.
So it is right.
Yes, del x del x tends to 0 is x plus del x tends to x as we added this, and in denominator only del x, that we can add x and we can subtract x, upper is same. We have considered, or we have changed in this form because we know the formula of limit. To apply the limit we change that formula of limit, you know that limit x tends to a xn minus an by x minus a equal to n a n minus 1. You have to remember this formula. Then here also limit this whole is x, we suppose x tends to a, x is a and x plus del x is a, x we suppose x tends to a xn minus an by x minus a format. So we can apply the formula n itself n, a is x and n minus 1. Therefore dy by dx equal to n x n minus 1. This formula is called the power rule. So if you need to find derivative of x cube equal simply 3x 3 minus 1, it will be 3 times x square. We can use this formula later one, but upper one is using first principle. We find the derivative of x to the power n. In the same way you can find any power of x, the derivative of any power of x you can find in this way. You can simply try this by alternative method as well.
Sure.